Hi students, this is Mr. Yang. Today we're going to talk about 1.8, where we will learn how to factor completely. This is kind of a difficult concept. If you can actually master this concept and know everything about factoring, do all of these examples correctly, you're going to be fine about any kind of factoring all through high school. So let's get started. Factor completely means to continuously factor terms until you are no longer able to factor anything. Basically, you just keep factoring it and don't stop until you cannot do it anymore. So a polynomial is called unfactorable or prime if you cannot even do any kind of factoring. If you cannot even take out a GCF at the beginning, that's going to be called unfactorable or prime. And here is a factoring flowchart. Basically, it walks you through the process of doing any kind of factoring. So we always start with GCF on the top. Then if we do, we factor out a GCF. If we don't, we're going to decide if it has 2 terms or 3 terms or maybe more than 3 terms. Then it has all different kind of methods. So you can look at this and see if there's any mistake. So you can look at this and see if there's any little things that you still don't quite understand about factoring. Now let's walk through 8 different examples. First one, we see 8n squared minus 50. The first thing I notice is I have 8 and negative 50. They do share 2, so I'm going to factor out the GCF 2. Then I have 4n squared minus 25 left. And if we pay attention, we can see 4n squared is a perfect square and 25 is also a perfect square. So that basically this question is difference of perfect squares. So I can use the formula that will give me 2n plus 5 and 2n minus 5 with a 2 in the front. If you're having trouble recognizing it as perfect squares, you can also do 4n squared plus 0n minus 25. And then do the cross method with negative 25 on the top and then 0 on the bottom. We just need to find 2 numbers that multiply to be negative 25 and adds up to 0. That can also work. Now example 2. So we see now we don't even have x squared in the front anymore. It's x to the 4th power. But the key is, if we pay attention, we can see it's a 4 and then a 2 and then basically a 0 on the end. So that still kind of have the relationship of being 2, 1, and 0. Because the first number is twice of the second number and then we have a 0 on the end. So what if I just rewrite this question? I'm going to say y equals x squared. So whenever I see x squared, I can rewrite it as y. That means when I see x to the 4th power, that can be rewritten as y squared. And then minus 10, I see x squared, so I replace it with y plus 24. Now this question becomes y squared minus 10y plus 24, which actually is a quadratic. So that means I can use my cross method. So I'm going to use my cross method, 24 on the top, negative 10 on the bottom. I can see the number pair is going to be negative 6 and negative 4. And I just need to put an extra y on the top. So after factoring, I will get y minus 6 times y minus 4. But I'm not done, because my question is not with y, it's actually with x. So now I need to put all the x back. I need to actually put the x squared to replace the y. That's going to give me x squared minus 6 times x squared minus 4. Now we need to see if we can keep factoring anything. X squared minus 6, we cannot do anything. But x squared minus 4, both of them are perfect squares. That means I can do difference of perfect square again. So the first part stays there, x squared minus 6. But the second part, if we use the formula, is going to be x plus 2 times x minus 2. If you're still struggling with recognizing difference of squares, you can go back to 1.7 and review the special cases. So for this question, after I dealt with the different squares, I'm done. Now let's look at example 3. This time I see x to the 6th power. Since 6 is still an even number, that basically means x to the 6th power is a perfect square. And 64 is also a perfect square. That means I can use the difference of square formula again. I will get x cubed plus 8 times x cubed minus 8. And now if I pay attention, both parentheses have x cubed. And 8 is also a cube. That means now I can use the cubes formula to deal with both of them. The first one, I will get x plus 2 times x squared minus 2x plus 4. The second one, I will get x minus 2 times x squared plus 2x plus 4. So altogether, I cannot factor anymore. That means all that is the answer for example 3. Now example 4. First, I see there is a GCF that I can take out, which is 3. So I'm going to take that out. I have x to the 4th power minus x squared plus x minus 1 left. Then I have 4 terms. I'm going to try factor by grouping. So that's going to factor out an x squared. Then I have x squared minus 1 left. For the second part, the GCF is basically a 1, and then I still have x minus 1 left. But don't forget, we still have this 3 on the outside. Next, problem is inside my parentheses, they're not even the same. So I cannot do anything right now. But if I look carefully, I can see that is x squared minus 1. It's difference of a perfect square again. I'm going to keep factoring that part. So x squared is still outside. That part is going to become x plus 1 times x minus 1. Then I have this plus 1 times x minus 1 on the end. And again, don't forget, we do still have the 3 on the outside. Now for both parts. I can see for the first section and the second section, I have one parenthesis that has x minus 1. That means I can factor that out. So I have x minus 1 taken out. Then what's left is going to be this x squared times x plus 1 plus 1. But again, we still have this 3 on the outside. But that second parenthesis has another parenthesis in there, and I do need to simplify. So that will become x squared times x, which is x cubed, then x squared times 1, which is just x squared. Then I have a plus 1 on the end, and I still have the 3 in the front. Now if I look again, there's nothing I can factor, and I'm done with example 4. Example 5. This question is kind of similar to example 2. I don't see the square to be the first term, but I do see a descending order. So I have 4, then I have 2, and then I have a 0. So that means I can actually use y again. I'm going to pretend y is actually x squared. Then I can rewrite this question to be 3y squared minus 13y plus 4. And then I can actually use my cross method. Draw a cross. 3 times 4 is 12 on the top. Then is negative 13 on the bottom. And the combination I can find is negative 12 and negative 1. And I'm actually going to switch them since I need more space. So I have negative 1 and negative 12. And I'm going to put 3y on the top. The left side cannot be simplified, but the right side can be, so that becomes y over negative 4. But I'm not done, because now I need to replace my y with x squared. That's going to give me 3x squared minus 1 times the x squared minus 4. First parentheses, no perfect squares, I cannot do anything, but second parenthesis, I do see perfect squares. That's a perfect square, and that is a perfect square. So I can use difference of squares to deal with that part. The first parenthesis stays the same. The second one becomes x plus 2 times x minus 2. And nothing else I can factor, so I'm done with example 5. Now example 6. First thing I do notice is they have GCF. At least they have an x. And then 216 divided by 27 actually is 8. So that means I can actually factor out a 27 as well. Then I'm left with 8x cubed plus 1. So after that, I can see 1 is a perfect cube, 8x cubed is also a perfect cube. That means I can use a cube formula. So 27x stays outside. For my cube formula, first thing, that is going to become 2a. Then I still have a plus 1. Second parenthesis is going to be the 2a squared, which is 4a squared, then minus 2a, and then plus 1. Nothing else I can factor. I'm done with example 6. Example 7. Now we have some big numbers, but I don't have to take out a big number. I can just start baby steps. I see they're both even numbers, so I'm just going to take out a 2. And then I'm left with 16n to the 4th power minus 1250 divided by 2 is 625. And now I do see an even number, which means this first term is actually a perfect square. 625 is also perfect square. That means I can use the difference of square formula. The 2 stays outside, and I'm going to need to find the square root of 16, which is 4. The square root of n to the 4th power is n squared, then plus square root of 625 is a 25. And the other parenthesis, I just need to change the plus sign to a minus sign. Now the first parenthesis, I have 4n squared plus 25. That's the sum of perfect squares. We cannot do anything to it, but the second parenthesis, I have perfect square right there, and that is the difference of perfect squares. So I can use the formula again. So the first one is that, and the second one is going to be 2n plus 5 times 2n minus 5. I'm done with that example. Last one, example 8. The first thing I see is GCF. So 40, 44, and 72, they at least share a 4. Then also, they all at least have a p. So I'm going to take that out and see what's left. 10p squared plus 11p minus 18. Okay, now I have a trinomial, a quadratic. I can use my cross method. I'm going to draw across. The top is the 10 times negative 18. So negative 180. And the bottom is 11. And the combination I need is a negative 9 and a positive 20. Then I'm going to put this 4, not 4. Then I'm going to put this 10p on the top. Since that is the leading coefficient, the right side can be simplified to be p over 2. So my final answer, 10p minus 9 times p plus 2. But don't forget, we still have that GCF in the front. That's going to stay there, 4p in the front. And that is our final answer. That is everything about factor completely. If you struggle with any specific example, please go back and watch it again. And that will be all. Thank you.